Cartesian product. Cartesian product, it is coming out of the board. Wait a second. Okay. Cartesian product. Now, Cartesian product is always defined between two given sets. Understand what we are doing. Let A and B be two given sets. Then all possible ordered pair, then set of all possible ordered pair A comma B, where first entry A is the element of set A and the second entry B is the element of set B. This kind of set is called Cartesian product of set A and set B, and is denoted by A cross B. Denoted by A cross B. Okay, understand what we are saying. Let's say two sets A and B are given. Then Cartesian product of set A and set B, first of all, it is denoted by A cross B. Okay. If we define B cross A, then this will be Cartesian product of set B with set A. Okay. Now, what is A cross B? Is basically a set. Now, the elements of the sets are basically ordered pair. Or if I say all possible ordered pair A comma B, where A is element of set A and B is element of set B. Understand this. With example, we will try to understand. Let's say set A is nothing but X comma Y comma Z. And let's say set B is nothing but 1, 2, 3. Okay. Now, if I am defining A cross B, then it will have all the ordered pairs possible, in which first entry will come from set A and the second entry will come from set B. So, if I start writing ordered pairs, so first entry will come from set A, let's say I am choosing X. Then the other second entry will come from set B, let's say I am choosing 1. Again, I am keeping X as it is and choosing 2. Again, I am keeping X as it is and choosing 3. So these are the three elements of the Cartesian product. Similarly, I can choose Y also. So Y comma 1, Y comma 2, Y comma 3. Similarly, I can choose Z comma 1, Z comma 2, Z comma 3. So Cartesian product between the two sets A and B is nothing but A cross B, which contains all possible, understand this, all possible ordered pair A comma B. Okay, that means first entry you will take all the elements of set A, B you will take all the elements of set B. Quickly copy this. Now, if I define, let's say, Cartesian product B cross A, then understand this B cross A will have elements ordered pair B comma A, where B is element of set B and A is element of set A. This type of element it will have. So you can define here also. So first entry is from set B. Let's say I'm choosing 1. Then other entry from set A, so 1 comma x, 1 comma y, 1 comma z, 2 comma x, 2 comma y, 2 comma z. Similarly, 3 comma x, 3 comma y, 3 comma z. It will be Cartesian product of set B with set A. Did you understand? Just type if you understood. Okay, good. Copy quickly. When you're done copying, just tell me. Don't take a screenshot.
Completed.
Okay, completed? Okay. So if I give you any set, if I give you any two sets, then it is very, very easy to find out its Cartesian product. Yes or no? Very, very easy. Okay, so I'm not going to indulge into those kind of questions. Very, very easy. Now let's come to relation. Relation. Relation between, let two sets A and B are given. Let two sets A and B are given. Then relation between two sets A and B, then relation between two sets A and B is denoted by ARB. It is denoted by ARB, where A is element of set A and B is element of set B. Okay? It is just the notation we are talking about. I have not defined relation yet. Relation between the two sets A and B is nothing but it is denoted by ARB, where A is element of set A and B is element of set B. This order definitely matters. Understand this properly. Now, what is a relation? In simple words, relation, in simple words, relation connects one element of set A with some element of the set B. It is basically a connection. Like when you, let's say, all of you, if I say all of you are basically connected to KVC, yes or no? All of you are student of KVC. So it is a relation. Similarly, if I let's say make a connection in between you guys only, all of you are friends. So let's say friend, if this kind of relation if I define, then I will be able to connect each and every one of you. So relation is nothing but, just like in real world, here also relation means the same thing. With some condition we will talk about. Okay. So relation is basically a subset of Cartesian product A cross B. I will explain it also. relation is basically a subset of a Cartesian product. It is basically a subset of Cartesian product A cross B. Understand, on this left hand side, can I rub this off? This left hand
Yes, sir,
side,
you
can I?
can.
Okay. Let's say this is your set A. Now in set A, we have taken X, Y, Z as the element. In set B, we have taken 1, 2, 3 as the element. Okay. Now what we are doing, let's say if I'm writing here in A cross B, we have written X comma 1, X comma 2, X comma 3, something like this, Y comma 1, Y comma 2, Y comma 3. So by using the ordered pair, basically we are connecting one element of the set A with the other element of set B. Yes or no? By using ordered pair, what we are doing? By using ordered pair, we are connecting two elements in which first element is coming from set A. The other element, the second element is coming from the set B. Okay. So if you see, if I represent this ordered pair here, then X is basically connected to 1, X is also connected to 2, X is also connected to 3. Similarly, Y is also connected to 1, Y is also connected to 2, Y is also connected to 3. Similarly, Z is also connected to 1, with 2 also, with 3 also. So this is nothing but our Cartesian product A cross B. Yes or no? In Cartesian product, all possible ordered pairs are taken as elements of the set. Yes or no? So here each and every element of set A is connected to each and every element of set B. So all ordered pairs are covered. X connected to 1, that means X comma 1. X connected to 2, that means X comma 2, X comma 3, Y comma 1, Y comma 2, Y comma 3, Z1, Z2, Z3. Okay. So this is basically, this diagram is basically depicting our Cartesian product of set A and set B. Okay. Now let's come to relation. What relation is? Relation is a connection between, again, two elements, let's say A and B. And any relation we can define. There are so many number of relation we can define. What we are basically saying? Relation is basically a subset of a Cartesian product. In Cartesian product, each and every element is connected to each and every element. Yes? Now in the relation, all possible subset, that means 2 to the power n, if you remember. So all possible subset will define different types of relation. Let me give you a simple example. Let's say I am defining one relation from set A to set B. Again X comma Y comma Z, and here 1 comma 2 comma 3. Let's say I'm connecting X with 1. I'm connecting X with 2 also. Let's say I'm connecting Y with 2 and Y with 3 also. Let's say I'm connecting Z with 1 and Z with 3 also. And I'm writing A R1B. That means R1 I have defined a relation from set A to set B such that the elements are X comma 1, X comma 2, Y comma 2, Y comma 3, Z comma 1 and Z comma 3. Yes or no? It is basically relation R1, but from set A to set B. That means elements of set A are connected with elements of the set B. Now, it is basically a subset of this Cartesian product or not? Yes, it is a subset. So it is one type of relation. I can define other relations also. Let's say again, this is your set A and this is your set B. Again, x comma y comma z, and this is 1, 2, 3. Let's say x comma 3, y comma 3, z comma 3. I am defining, let's say, relation number 2, A R to B. So R2 has elements x comma 3, y comma 3, z comma 3. X comma 3, y comma 3, z comma 3. Did you understand now? Quickly copy. See, these online classes will also be good if you start interacting with me. In the offline classes, we were interacting every day. Similarly, in these online classes also, because this is because of restriction. In online classes also, we have the facility, so you can directly interact with me and you will feel like you are sitting in the classroom. Completed? All of you?
Yes, sir, completed.
At least this right hand side, can I rub this off?
Yes, sir.
So you understand what a relation is. Relation is nothing but, yes, relation is nothing but a connection between two elements, two sets. Okay, connection between the two. So how we are defining, let's say set A is given, set B is given. So some elements of set A we are connecting with some element of set B. This connection, the set of all these connection is basically your relation, one of the relation we have defined. Similarly, other relation also we can define. Just let me give you an example. Let's say set A contains 1, 2, 3. Set B contains, let's say, 4, 5, 6. It can have different number of elements also. Let's say here I'm taking 7. Now ARB, or let's say AR1B, I'm defining in such a way. Understand, I am using set builder form. A comma B slash A plus B is E1. This is our set builder form. Now let's convert it into our tabular or roster form. If A plus B is even, then if I'm choosing 1, then I cannot choose 4, I cannot choose 6, because 1 plus 4 is odd, 1 plus 6 is odd. So I will be choosing 1 and 5 or 1 and 7. So 1 comma 5 comma 1 comma 7. That means 1 is connected to 5. Under which relation? That A plus B is even. 1 is connected to 7 also, because 1 plus 7 is even. So that relation we have defined. Similarly, if I choose 2, then I cannot choose 5 or 7. I will choose 2. I will choose 4 and 6. So 2 comma 4, 2 comma 6. Similarly, 3 comma 5 and 3 comma 7. Yes or no? On the diagram, I can show like this. This is your 1, 2, 3. This is your 4, 5, 6, 7. So 1 is connected to 5. 1 is connected to 7. 3 is also connected to 5. 3 is also connected to 7. 2 is connected to 4 and 2 is connected to 6. This is your R1. This is your R1 relation. Yes or no? Similarly, I can define AR to B, okay? AR to B, which is nothing but again a relation such that A plus B is odd number. A plus B is an odd number. This is your homework. You can do it easily, okay? So you have got an idea how we are defining basically relations, okay? So this R2 relation you will do from your side. This R2 you will do from your side. Very, very straightforward. Now understand. I will define, let's say, domain and range of a relation. Domain and range of a relation. Okay? So first of all, understand this properly. Domain and range will depend upon which relation we have defined. If relation is different, then your domain and range will also differ. Understand? Let's say I am defining R1 having entries, let's say 1, 2, 1, 3, 1, 4. And R2 I am defining 2, 4, 2, 5, 2, 9. Or let's say 3, 9. Okay? So domain is nothing but all the first entries of a relation. Domain is nothing but set of all first entries of a relation. Understand? If I'm talking about domain of this R1, then can I say domain 1, can I say it is basically set of all the first entries. Here only one will come in the domain of this relation R1 because we have only 1, 1, 1. Only one element is there. Okay. If I'm talking about domain of R2, then first entry, that means 2, 2, 3, that means 2, 3 will be my domain set. Okay. Similarly, if I define range set, let's say range 1, range is nothing but set of all second entries. Range is nothing but, I will dictate here also, I will write it down also. Range is nothing but all set of all second entries. Range is nothing but set of all second entries. So if you see for the first relation 2, 3, 4, 2, 3, 4 will become set of my range. In the case of R2, range will become 4, 5, 9, 4, 5, 9. Okay, so let's write it also. So domain of a relation is nothing but set of all first entries of a given relation of a given relation. Okay, you can correlate with our function domain also, function range also. Function changes, your domain changes. Here also, your relation changes, your domain will change. Similarly, range of a relation, range of a relation is nothing but set of all second entries of a given relation is called your range set. I don't think I need to give examples here. This is enough. Quickly copy.
Yes, sir, completed.
Done? Okay. Now, let's come back to our Cartesian product. In Cartesian product, each and every element were connected with each and every element of set B. Yes or no? And how did we define relation? Relation we defined in such a way that it is basically a subset of our Cartesian product. It is basically a subset of our Cartesian product. In Cartesian product, each and every element connected to each and every element here. In subset, we have different types of subsets possible. Okay, it is possible that X is connected to 1, Y is connected to 2, and Z is connected to 3 only. It is also possible that X, Y, Z all are connected to 2 only. It is also possible that X is connected to 1 and Y is connected to 3. That's all. That is also a relation. Okay. So depending upon types of relation, depending upon how many elements, how many connections we are choosing, we can define different types of relation also. Understand this once again? Depending upon how many connections we are choosing and in what way we are choosing the connection, we can define different types of relation. So let's come to types of relation. Very important topic from your JEE main point of view. Types of relation. First is your empty relation. Empty relation. Understand, when we were covering subset, I told you, when we were discussing subset, I told you your null set will always be a subset of each and every set. If you remember, null set will always be a subset of each and every set. Yes or no? So, A cross B, it is also a set. And in the relation, we are considering subset of this Cartesian product. So, first of all, I am considering your null set. Null set means, if you understand, null set means no element of set A is connected to any element of set B. No element of set A is connected to any element of set B is basically called empty relation. That means there is no connection between any element of set A and any element of set B. There is no connection. So it is basically empty relation. So empty relation when no element of set A is connected to any element of set B. When no element of set A is connected to any element of set B. So is it a proper subset or an improper subset? This first one, is it a proper subset or improper subset?
Improper.
Improper subset, because we are not taking any element from this Cartesian product. So it is basically our improper subset. The other improper subset, is when we take all the elements. That relation is called universal relation. Universal relation. Universal relation, what it means? That means each and every element of set A is connected to each and every element of set B. Let's say in our class, all these students, let's say first entry and second entry, I am connecting with the property that these are student of KVC. So I can connect each and every one of you with each and every other student. In fact, I can connect you with our first year students also. Yes or no? Each and every student. Because the property that I defined is, the connection that I'm defining is, you must be student of KBC. They are also student, you are also student. So definitely I can connect each and every one of you with each and every one of first year student. Okay. So it is basically universal relation. In universal relation, each and every element must be connected with each and every element of set B. Okay. That means if I say universal relation, that means I am actually talking about my Cartesian product A cross B itself. Yes or no? I told you relation is a subset. Relation is a subset of Cartesian product. That's what I defined. Yes or no? So we considered empty relation. Empty relation is basically your improper subset. Other improper subset when I consider A cross B itself. Now A cross B, it is nothing but my universal relation when each and every element of set A is connected to each and every element of set B. Here, when each and every element of set A is connected to each and every element of set B. That means we are talking about A cross B itself. A cross B is your universal relation. Quickly copy.
Completed, sir.
Done? Okay. Now we will define proper subsets. These two were improper and we gave them names empty as well as universal. Now other proper subsets, let's come and define. Third one, let's say identity relation. Identity relation. Understand identity relation. Let's say this is your set A and this is your set B. X, Y, Z. First of all, identity relation is always defined from the same set to the same set. Okay? Identity relation is defined between the same set. Understand why it is so? I will explain to you. X comma Y comma Z. Now your identity relation is a relation when each and every element is connected to itself only in a set A. Identity relation when each and every element is connected to itself only, is connected to itself only. That means we are talking about a relation from same set to same set. Okay. Now, how they are connected? How they are connected? If you are taking one element, then it can be connected with itself only, with no any, it cannot be connected with any other element. Understand what it is saying? When each and every element is connected with itself, that means X is connected to X, Y is connected to Y, Z is connected to Z. And it is saying only. That means X can never be connected to Y. X can never be connected with Z. Y can never be connected with X. Y can never be connected with Z. Similarly, Z cannot be connected with X or Z cannot be connected with Y. So, identity relation, it is basically defined by X comma X, Y comma Y, Z comma Z, Z comma Z. Now, if I define another relation, let's say I1, X comma X, Y comma Y, tell me, is it a identity relation? I1? This I1, is it a identity relation or not?
Yes, sir.
Okay. Anybody else? Vaishnavi, Preeti, Ganesh, Sanjay? No? Understand. In identity relation, each and every element must be connected. That means no element should be left out. No element should be left out. Each and every element, first of all, they all must be used and with each other only, with itself only. Okay. So I1 is not an identity relation. I is the identity relation. Okay. Did you understand? Or can I say here must be connected to itself only. That means each and every element must be present for the relation. Okay. A similar type of relation I will define reflexive relation. This is important chapter. Relation, it is an important chapter from your JEE main point of view. Directly questions come. You can see your previous year's questions also. You will find directly questions are asked from this topic. And it is a very, very easy topic. Now, reflexive relations, understand. It is a relation in which each and every element must be connected to itself. Reflexive relation, it is a relation in which each and every element must be connected to itself. Again, same definition as of identity relation also, we use the same definition. In our reflexive, also we are using the same definition. It is a relation in which each and every element must be connected to itself. Understand now? Again, let's say set A, and this is also set A, X, Y, Z, X, Y, Z. So let's start fulfilling all the condition in this reflexive relation. Each and every element must be connected to itself. That means X must be connected to X, Y must be connected to Y, Z must be connected to Z. Yes or no? But there is one difference. Here I use the word only. That means in identity, X cannot be connected to Y or Z. Similarly, Y can never be connected to X or Z. Here, it is possible that X can be connected to Y, or Y can be connected to X, or Y can be connected to Z. Minimum condition in reflexive relation is each and every element must be connected to itself. After that, if they are connected to other elements also, we don't have any problem. Okay? So, reflexive relation, if I define X comma X, Y comma Y, Z comma Z. Let's say R1 I am defining. Okay? So minimum condition must be fulfilled. After that we have something or not doesn't really matter. If I define R2, X comma X, Y comma Y, Z comma Z, let's say X comma Z, Y comma X, R1 and R2, which one is your reflexive relation?
Both, sir.
Both are? Both
Reflex.
are. Okay. I told you minimum condition must be fulfilled. In your R1 relation, each and every element is connected to itself. So it is basically your identity relation as well as reflexive also. It is your identity relation as well as reflexive also. R2, it is also your reflexive relation, but not an identity relation. R2 is your reflexive, but not identity. But not an identity relation. Understand this properly, okay? So based on this, can I say every identity relation is a reflexive relation? Can I say this?
Yes, sir.
Every identity relation is a reflexive relation. Is a reflexive relation. Did you understand? But can I say every reflexive relation is a identity relation? Can I say that?
No, sir.
Yes, very good. Yes means converse is not true. Only identity relation, it is a reflexive relation. All reflexive relation are not identity relation. R2 is your reflexive but not an identity. Quickly copy. Completed? Okay. This left hand side also, I am going to clean this off. Fifth one, symmetric relation. Symmetric relation or relation from A to B, A to B is said to be symmetric relation if A comma B is element of that relation, then B comma A must also be element of that relation. Symmetric, just go by the words, the meaning of the word symmetric. Okay. Now, if A comma B is element of this relation, then by interchanging their position, they must also be element of the same relation. Okay. Here, it is better if I write set A to set A. Okay. Understand this. Let's say again I am taking A and A. X, Y, Z. X, Y, Z. Okay. Let's say I connect X and Y. This connection is giving me X comma Y. If this is a symmetric relation, then Y comma X must also be element of the same relation. That means Y must also get connected to X. Okay. Let's say Y is connected to Z. This relation is giving me Y is connected to Z. That means Z must also be connected to Y. That means Z must also be connected to Y. You understand this? Tell me R1 and R2, which one is your reflexive and which one is not your, sorry, which one is your symmetric and which one is not symmetric? This right hand side, can I clean this off? This reflexive relation part.
Yes, sir.
Now tell me R1 and R2, which one is symmetric and which one is not symmetric?
R2 is a symmetric.
R2 is symmetric.
Yes, sir.
And R1? R1 symmetric. What about R2?
R1 symmetric, R2 not symmetric.
R1 is
symmetric,
symmetric,
sir.
R2 is not. Okay, let's see. See, whenever you want to check whether a given relation is symmetric or not, you will directly start examining the elements of the set. X comma y. That means y comma x must also be present here. Yes, y comma x is here. Now y comma x is here. That means x comma y must also be here. That means yes, it is completing itself, these two elements. Now y comma z and z comma y. Yes, x comma x. If I interchange their position, again I will get x comma x, which is present here. So yes, R1 is my symmetric relation. Let's come to R2. X comma y. That means for this relation to be a symmetric relation, y comma x must also be present. Do we have y comma x? Yes, we have y comma x. Yes, this condition for the first element, symmetric condition is satisfied. Y comma z and z comma y, again it is satisfied. X comma x, again it is getting satisfied. Y comma y, again satisfied. X comma z. Here is the problem. If x comma z is the element, then z comma x must also be element. Do we have z comma x? We don't have z comma x. We don't have z comma x. So R2 is not your symmetric relation. Only R1 is your symmetric relation. Did you understand this?
Yes, sir.
Okay. We have not discussed any question yet because some relation are still left. Once we have covered those, then we will be able to discuss your board level, your JEE main level questions. Okay. So in the next class, we will discuss that properly.